Robust programming focuses on creating software that is reliable, error-resistant, and easy to maintain. This involves ensuring the program can handle unexpected or invalid inputs, allowing only authorized users to access certain functionalities, and designing code that is both functional and comprehensible to others who may work with it in the future. Input validation is a critical component of robust programming. It involves checking that the data entered into a program meets predefined criteria before the program processes it. This could include verifying that a user enters a number where required, ensuring email addresses are in the correct format, or limiting input length to prevent issues like buffer overflow. For example, if a program asks for a user's age, input validation ensures that only a numeric value within a reasonable range such as 0 to 120 is accepted. Input validation prevents errors and protects against security vulnerabilities such as SQL injection, where malicious users attempt to input harmful code into text fields to exploit a program's database. Authentication is another essential aspect of robust programming. It ensures that only approved users can access sensitive data or perform specific operations. This process typically involves requiring a username and password, though more advanced methods such as biometrics, two-factor authentication, or token-based systems can also be used. For example, an online banking system might require customers to enter their login credentials and verify their identity using a one-time code sent to their phone. Authentication safeguards private information and prevents unauthorized access to systems, reducing the risk of data breaches. Clear and readable code is fundamental to robust programming. Writing code that is easy to understand not only helps other developers, but also aids the original programmer in revisiting the code for updates or debugging. Techniques to achieve clarity include using descriptive variable and function names, organizing code into logical sections, and avoiding overly complex logic that can confuse readers. For example, naming a variable total cost instead of $x immediately communicates its purpose, making the program more intuitive. Things that make code easier to understand include consistent formatting, such as indentation and spacing, and the use of comments to explain the purpose of specific sections. Consistent formatting allows readers to follow the structure of the program, while comments can clarify the intent behind complex or non-obvious lines of code. For instance, a comment like, "Calculate total cost including tax" above a line of code can prevent misunderstandings about its purpose. Another way to improve readability is to follow programming conventions and standards relevant to the language being used, such as adhering to PEP 8 for Python. These conventions ensure a uniform style that others in the programming community will recognize. Robust programming is about more than making code functional. It is about anticipating potential problems, ensuring security, and creating software that is easy to use, maintain, and understand. By incorporating input validation, authentication, and clear coding practices, programmers can develop reliable and maintainable systems that meet user needs while minimizing errors and vulnerabilities.